Right, so I'm going to do the solutions to these problems that I gave you. So scientific research has shown that the risk of having a car accident increases exponentially as the risk of alcohol in the blood increases. Sorry, as the concentration of alcohol, that makes more sense. The risk of an accident can be modelled following this equation. So I definitely said this before, but hopefully you remembered. I'm going to have to go and get my calculator here, but anyway. That 6.e is like 6 multiplied by e to the 12.8 c. So it says or is the risk of having an accident. C is the blood alcohol concentration. So that's that. E we know, it's just exponential. The legal limit for driving in Ireland is a blood alcohol concentration of 0.05%. Okay, so it does say here that it's going to be in percent, so that's fine. What is the risk of having an accident with this blood concentration? Okay, let's see what comes out here. So it's 6 times E to the 12.8 times 0.05. Okay, hang on, pause for a second while I get my calculator. Right, so 6 times E, 12.8 times 0.05, close the big bracket. So I'm getting or is 11.38. Assuming that's always also a percentage. So the legal limit for driving. So if you're at the legal limit for driving, your chances of an accident, it's a bit concerning, is it? Just over 11%. Find the blood alcohol concentration that corresponds to a 25% risk. So 25% risk means or is 25. So just write this down. Or is 6 times e to the, was it 12.8? Yeah, 12.8 c. So this time we have or, and that's 6 e to the 12.8 c. So we'll divide by 6 to get rid of that. Divide by 6 on this side. That's 4.16 recurring. I might just leave it as a fraction. Fraction's easier to type into your calculator than a recurring. Okay, the variables up here in the power, which means we'll have to switch to logs. So it's log to the base e of 25 over 6 equals 12.8 c. Log to the base e is the same as ln. So ln of 25 over 6 equals 12.8 c. So it's 1.427 and there's more numbers, which I'm keeping in my calculator. 12.8 c, and then we're going to divide by 12.8 to cancel the 12.8 and isolate the c, and divide this number, which is still in my calculator, by 12.8. So 0. They did 2 decimal places, did they? 0.05, yeah, so we'll do 0.11. So a little over twice the legal limit, 25%. It's very interesting. The blood alcohol concentration of a male drinker is given by this, where U is the number of standard drink units consumed, M is the body mass of the drinker in kilograms, and T is the time over which the drinks are consumed. A man with a body mass of 82 kilograms has 3 beers, which is equivalent to 5.8 standard units, over a period of 90 minutes. If the man decides to drive home, estimate the risk. Okay, so this is giving me C. Ooh, this is interesting. So C is 1.668. U is the number of drink units, which was this. So that's 5.0. .8. M is the mass in kilograms, and that's 82. And then minus 0.015 times T. And T is the time over which the drinks are consumed in hours, and this is 90 minutes, so that's going to be 1.5 hours. Okay. So 1.668 multiplied by 5.8 divided by 82 minus 0.15 and 1.5. So that is 0.095, and again it continues, and I'm going to keep it in my calculator. So then we need to go back to the other one to find the risk. So it was 6 times e to the 12.8c. So that's 6 times e to the 12.8 times this number up above, which again, I have the full number in my calculator. So I'm going to multiply that by 12.8 to e to the power of that number, and then multiply by 6. Ooh. So he has a 20.4% risk of having an accident. Okay, question 2. The increase in the human global population over a given period of time can approximately modelled using the formula PT equals AE to the BT. PT is the population after T years, A represents the population at the start of the period, B represents the percentage yearly increase as a decimal, and T represents the time in years. The human population in 1970 is 3.07 billion. The human population in 1990 had increased to 4.5 billion. Find the percentage yearly increase, assuming that the population growth follows the exponential pattern. Find the percentage yearly increase. That's time. The percentage. So we're looking for B, is that right? The percentage yearly increase, B is the percentage yearly increase. Okay, so if we go with the okay, so P T equals AE to the BT. Like, A is just going to be 3.07 billion, isn't it? Because that's the start of the period. The population after T years is going to be 4.58 billion, because that's what they've given us. So 4.58 equals 3.07 E to the B. Now, how many years is that? $20 years. So if I divide by 3.07, divide by 3.07. Oh, it's not a pleasant number. So again, I'm just going to leave it as a fraction. So 458 over 307 equals e to the 20b. The variable is in the power, so we switch to logs. So it's log to the base e of 458 over 307 equals 20b. Log to the base e is ln. So ln of 458 over 307 equals 20b. So it's 0.4 approximately, although there are more numbers. It's 20b, and then we'll divide by 20. So it's 0.02. That's as a decimal. So as a percentage, I'd need to multiply by 100. So a 2% yearly increase. According to the model, what is the human global population in 2016? Okay, so this is where we don't know the population. A is still going to be 3.07 because that's where it started. E is E, fine. B we now know to be 0.02. Now, 1990 to 20... Oh. So from 1970 to 2000, we have 30 years. And then obviously from 2000 to 2016, we have 16 years. So that's 46 years altogether. Does that seem right? Okay, so 46 times 0.02. E to the power of that multiplied by 3.07. I'm getting a population of 7.7 billion by 2016. Seems kind of logical. In what year does the model predict the global population will hit 10 billion? Okay, so PT, AE to the BT. 10 billion is our aim, or I don't know if that's the way you say it. It is for this question anyway. So 3.07 is A. E, this is 0.02, and this we don't know is T. Yeah. Okay, we've done this maths a few times already. So 3.07, if I divide... again, it's not great, so we'll leave it as a decimal. Or, sorry, we leave it as a fraction. Equals e to the 0.02t. The variables in the power, so switch to logs. It's a natural log again. So we're going to do the ln of 1,000 over 307. And that, oh, does not equal e. That equals 0.02t. So the ln is 1.1809. And again, there are more digits that I have in my calculator. And then I'm going to take the number in my calculator and divide it by 0.02. 59 years. So it's 59.04 years after, what was it, 1970? So somewhere in the year 2029? Okay. These are good questions. Very interesting. Did I give you any more? I did. So the temperature T measured in degrees Celsius inside a microwave oven after it has been turned on at full power for T minutes is given by the following formula. Okay, A and B are constants. The temperature measured inside the microwave over a period of 3 minutes is shown as. So it starts at 25 degrees, which is about room temperature. After 1 minute, it's at 70.38. After 2 minutes, blah, blah. Find the value of A and B. Okay, so we always use this to find one of them because it eliminates a variable. So the temperature, T is 25. 500 minus A times 0.8 to the b, and the time there is 0. So that is 500 minus, equals minus a times 0.8 to the power of 0, because b times 0 is 0. 25 minus 5, oh my god, equals 500 minus a. Anything raised to the power of 0 is 1. So 25 equals 500 minus a, and then we can just algebra our way out of this one. So just made it positive, and then I'm going to minus the 25 to get rid of it here, and minus the 25 over here. So a is isolated on the left hand side, and then 500 minus 25 is 475 for a. And now I should be able to use this one to get b. So t is now 70.38. 500 is still 500 minus, I know a now is 475 because they said it was a constant. And then we have 0.8 to the b, I don't know, oh, b I'm trying to find. And this is 1. Okay. So 70.38 equals 500 minus 475 times 0.8 to the power of b. I'm going to plus all this to get it to cancel, and plus it over here. And then I'll minus the 70.38 to get rid of it here and put it over here. Yeah. So on the left hand side, I have 475 times 0.8 to the power of b. And on the right hand side, I have 500 minus 70.38, which is 429.62. I'm going to divide by 475. So that divided by 475. So 0.8 to the power of b. I don't need the brackets anymore, actually. Equals 0.9044. And again, there are more numbers. The variable is in the power, so switch to logs. So it's log to the base 0.8 of 0.9044 with my extra numbers equals b. So log to the base 0.8. Oh, I didn't write 0.8, sorry. Log of 0.8 of a. So I'm getting b to be, I think I said 2 decimal places. Yeah, 2 decimal places, 0.45. It's 0.44999. Okay, find the temperature inside the microwave after 273 seconds. Okay, so T equals 500 minus A, 475, and then 0.8, am I right? BT. So B is 0.45 and T is 273, because that's what this question is about. So that should just go straight in. God, I'm getting 500 degrees Celsius. I'm just going to check the maths there on that. Oh, hang on now. sorry, I know what I did. The time has to be in minutes. Okay, so that's where I'm wrong. I knew that didn't make any sense. So the time has to be in minutes. So 273 divided by 60. So this is 4.55 minutes. So put that in there. That should make a bit more sense. Okay, let's try it again. Multiplied by 475 and then 500 minus the answer. That makes so 199.2 degrees Celsius, which seems fine. How long will it take the temperature to reach 300 degrees? So again, I don't know this one, but the temperature is, so it's 500 minus 475 times 0.8 to the 0.45 T. Okay, and how long? So it's this we're given. So 300 equals 500 minus 475 times 0.8 to the 0.45 T. Again, I think I'm going to plus this. It's just always easier to get rid of those negatives. You don't have to. Okay, and then I want to get rid of that 300, so I'm going to minus 300 to cancel it, and then minus 300 over here. All right, so I know it's messy, but on the left-hand side, the only thing I have is the green writing. It's not cancelled out. So that's the green writing, and on the right-hand side, I have 500 minus 300, which is 200. I'm going to divide by 475, divide by 475. So I get 0.8 to the 0.45 T equals, oh God, again, messy decimals, so we'll leave it as a fraction. Variables in the power yet again, so we'll switch to log. So it's log to the base 0.8 of 8 over 19 equals 0.45 T, which is the power. Log to the base 0.8. So this is 3.876, and there are more digits, which I'm keeping in my calculator. And then I'm going to divide by 0.45 to isolate the T, and divide by 0.45 on this side. So that gives me 8, does give me decimal place, so 8.6 minutes. Okay. Fine. Oh, sorry. You can't do this one. This is a calculus question. Oh, not calculate, calculus. So the rate at which the temperature inside the microwave is increasing, we would have to differentiate the function there, which you can't do yet. You can't do yet. So don't worry about that one. That's not one you have the maths to do yet. And is that it? It is. Okay, so that's all those solutions for you.